So welcome again. I hope I am audible to all of you. Yes, okay. So as we already started with the gas chromatography, we will extend by 5 to 10 minutes more, okay? So we were dealt with this man called as John Porter Martin. Remember the more specific term in case of gas chromatography, which I have already said, is liquid gas chromatograph. Okay, liquid gas chromatograph is more appropriate term. Okay, so we were discussing about this GLC and GSC. Okay, as the name suggests, they are gas solid chromatography and a gas liquid chromatography. Okay, so in this case, gas is a mobile phase. Remember the speciality of gas chromatography, as already said, that mobile phase in this case is a gaseous substance. Okay, now in case of stationary phase, it is solid or liquid. Okay, and that's why there are two terms or two specific techniques called as GSC and GLC depending upon the use of a mobile phase. Okay, now when you call it as a GSC, it is a gas solid chromatography, but it is of limited use compared to the GLC. Okay, because not used because of its limited number of stationary phases. The stationary phase which required for the adsorption of your gas on the stationary phase or a inert solid substance is not available in a quantity or in a number, and that's why this GSC is limited in its use, and that's why GLC, remember GLC is synonymously called as your gas chromatography, just because GSC has its limited use in case of stationary phase. Okay, yes, okay, as we all know, when there is a stationary phase as a solid, okay, if the stationary phase in case of any chromatography is a solid, then the principle is called as adsorption. That means the separation in case of solid stationary phase will be dependent upon the adsorptability of the molecule. Okay, now if you have GLC, okay, the liquid chromatography or a liquid as a stationary phase, then there is a definite chance of separation. In case of this is a partition. That means when there is a stationary solid phase, the separation will be dealt with the help of adsorption principle, and when there is a liquid as a stationary phase, then it is called as your partition, or rather the principle based upon the separation is called as your partition. Okay, now the sample, the foremost requirement which already dealt with, that separation of gaseous, remember gaseous and volatile substances. If suppose your compound is not gaseous enough, you need to convert it into gases or a vaporized state. Remember, the sample needs to be in the gaseous state, and that's why if it is not, then you need to convert it into the vapors. Okay, need to convert into the vapor and mix with the gaseous mobile phase. Then depending upon the vapor pressure of your mobile phase, depending upon the vapor pressure created by the sample gaseous phase, this phase and sample get mixed with each other, and separation will be possible on the basis of their partition between the stationary phase and a mobile phase. Okay, yes, good morning to all of you. Now as we all know, if the component, sample component, more soluble with the stationary phase, now in case of this, it not only the solubility, that means the polarity or non-polarity of your molecule or a sample component, but its intermolecular interaction. Its intermolecular interaction with the stationary phase will be the determinant in case of retention time. Remember, how molecule reacts with the stationary phase will be dependent upon the polarity as well as your intermolecular attraction. Now, if the molecule shows highest amount of affinity, highest amount of attraction, highest amount of interaction with stationary phase, it results into the attraction or attachment of your molecule to the stationary phase. That means it travels slower. Remember, if your molecule will get attracted more strongly or will show more affinity towards the stationary phase, that means it gets attached and will be traveling very slowly as compared to the molecule which is less soluble or less attracted to the stationary phase, which travels faster. That means the peak which you get first will be of a component which is less soluble or less attracted or will show a less interaction with the stationary phase as compared to the component which shows a stronger affinity, highest affinity, or a strong molecular interaction with the stationary phase. Okay, so I hope this is clear to all of you. Yes. Now the components are separated according to their partition coefficient. Remember, when we say a gas chromatography, remember the picture of most of the time gas liquid chromatography. When we say gas chromatography, remember the picture of gas liquid chromatography because of certain limitations with respect to your GSC. Okay, the stationary phase which we need in case of gaseous substances is limited of a choice, and that's why the only option remaining is gas liquid chromatography. And if it is a liquid, the separation will definitely be dependent upon the partition coefficients capability of a sample in between the stationary phase and a mobile phase. Okay, now criteria for the compounds to be analyzed by gas chromatography. Okay, criteria which you need to be analyzed. What should be the compound's characteristics? In case of gas chromatography, if you want to perform the gas chromatography of any unknown substance or any known substance, what should be the characteristics or what should be the properties of that compound? There are two possible and more important properties are it should be volatile or it should be converted into the vapor state by a limited heating. Remember, volatility or conversion of your compound into the gaseous state is a prime requirement in case of gas chromatographic separation. That means if your compound will show the highest or rather appropriate amount of volatility in that particular temperature conditions, that compound can be easily determined by gas chromatography. This is the first criteria. Second is thermally stable, thermostability. Remember, if your compound is in liquid state and you are going to vaporize that compound with the help of heating, or you are externally apply any form of heating element to it, it results into the destabilization of your compound. Its physical structure will be getting changed, but that physical structure will not result into any chemical degradation. Remember, thermal stability will be that it should be physically unstable. In the case that the liquid may be converted into the gaseous state, that should be permitted, but the chemical stability, that means its chemical interaction, its chemical inherent properties will not get hampered, so that means it is a thermostable. Thermostable means it is chemically stable. Okay, because you are going to heat the compound. These two are the prime criteria for a compound to be get analyzed under the gas chromatography. First is the compound should be and must be volatile so that it can be converted into the gaseous state, and while conversion into the gaseous state it should remain thermally stable. Okay. Now what are the advantages with respect to this technique? Okay, what are the advantages with respect to this technique? The use of longer columns and higher velocity of a carrier gas. Remember the Van Dimter equation. Longer the columns, longer will be the surfaces available for the attachment of a compound into the stationary phase, and the composure or exposure of your stationary phase will be higher, there are chances that your sample components will be get separated very easily. Apart from this, as we have learned in case of your HPLC, high pressure will result into the pressurized gaseous liquid system or a mobile phase more specifically into the column will result into the separation more easily as well as very fast. So these two combined technique can be easily advantageous for gas chromatography because it utilizes the longer column and just because of the carrier gas. Now in case of gas chromatography, we were not going to talk in case of mobile phase, we will synonymously call it as a carrier gas. Remember, the mobile phase in case of gas chromatography synonymously called as a carrier gas, and as it is present in the form of gas will show the highest amount of velocity, no need to discuss it. Okay, now higher working temperatures, as we already know that our compound needs to be in the gaseous phase, and if your compound will not be in the gaseous stage, it should be heated so that it can be converted into the volatile form or a gaseous form. So the working temperature in case of gas chromatography can be up to, that should be degree, okay, 500 degrees Celsius. Remember, the working temperature at this stage is 500 degrees Celsius, and possibility of converting any material into the volatile component make the gas chromatography one of the most versatile techniques. Remember, this is a double-edged sword. In case of this may cause advantage also and this may cause a disadvantage also. Advantage is what? At a 500 degrees Celsius you can convert most of the compounds into the volatile components for gas chromatography, but remember there is a disadvantage with respect to this also. I am going to discuss it in the disadvantage. Okay, so GC is popular in case of environmental monitoring in industrial applications. Remember, the more specific application in case of GC is environmental monitoring and industrial applications, because it is in case of environmental monitoring very reliable and can run continuously. It does not result into any form of choking or any form of hindrance. So it is very reliable technique and can be nearly continuously run for environmental monitoring and industrial application. Okay, now GC is typically used in applications where, remember, there are two terms, small and volatile molecules. Okay, as we already know that the compound needs to be the volatile. Okay, the compound which needs to be the volatile, but remember the small means molecular weight should be low. Okay, its molecular weight should be low, and second criteria is it should be volatile molecule. Okay, so these two components will result into its advantages. Okay. Yes, GC favored for non-polar molecules. Remember, GC, as in case of your liquid chromatography, will favor the non-polar molecules. Okay, these are some of the advantages with respect to your gas chromatography. I am going to repeat it again very fast. Use of longer column and higher velocity carrier gas. Working temperature is high, so most of the compounds can be converted into the volatile components. Popular in case of environmental monitoring and industrial applications. Typically used in applications where the small and volatile molecules can be employed, and favored for non-polar molecules. Despite of certain advantages, there are certain disadvantages, or rather more specifically limitations associated with your gas chromatographic technique. Now what are the limitations? Compound to be analyzed should be stable under the GC operations conditions. Remember, what is the advantage? That the working temperature, in case second point over here is working temperature can be extended up to 500 degrees Celsius. Now 500 degrees Celsius will not yield, or rather will not get you the stable molecule in most of the times. Remember, the compound to be analyzed needs to be thermally stable, and if you are employing such a higher temperature, there are possibilities that the stability of a compound will be affected and it may degrade into the individual components, and these components will not result into the efficient resolution and separation through the gas chromatographic operations. components. Okay, so this is one of the major limitation in case of gas chromatography. Second, they should have the vapor pressure significantly greater than the 0. The compound which is going to be analyzed needs to be have the vapor pressure which is greater than the 0. Then and then only they can form a very efficient amount of partition coefficient capability, and then only they can be get separated out easily. If they cannot produce sufficient amount of vapor pressure, they cannot be get separated. Remember. Okay, so third point, typically the compounds analyzed are less than 100,000 Dalton because it is difficult to vaporize the larger compounds. As I already said, what is the advantage with respect to this fourth point? Remember, GC can be applied for smaller molecules. Smaller means in this is 1000 Daltons molecules. Its molecular weight will be less than 1000 Daltons, because the Dalton, as the Dalton increases, it is becomes really difficult for a compound to vaporize, and that's why this is the another limitation in case of your gas chromatography. The samples are also required to be salt free. They should not contain the ions, because ions will not only result into the hindrance in your separation, but they may get stuck inside the column and you will not get the sufficient amount of separation. That's why the samples needs to be salt free. Remember, sample needs to be salt free. In a pure vaporized form, the compound can be easily isolated. Very minute amounts of substances can be measured, but it is often required that the sample must be measured in comparison to the sample containing the pure suspected substance known as a reference standard. Most of the times you need to have a reference compound. Remember, you must be knowing this term called as a reference standard. That means the pure compound of the unknown substance or a known substance. Okay, the pure compound needs to be there so that we can compare the reference standard with the amount. And this is also one of the disadvantage, because you need for most of the times the reference standard, and if you don't have the reference standard, it becomes really difficult to separate out the individual components and perform the identification test for the gas chromatographic separation components. Okay, so these are some of the advantages and these are some of the disadvantages. Now, how this gas chromatographic machine works? Okay, in a simple terms, how the gas chromatographic machine works. Okay, now what is the first term in case of this? A vaporized sample is injected onto the chromatographic column. Remember, the vaporized sample is injected into the chromatographic column. Remember, the compound needs to be in the vaporized form. Second, the sample moves through the column through the flow of inert gas, which is also called as a carrier gas. Carrier gas in case of this is helium most of the times, because it is thermally stable, it is inactive, it is inert, and that's why the choice of solvent, mobile phase, or rather more specifically carrier gas in case of gas chromatography is a helium. Okay, now this helium or inert gas or carrier gas carries the molecules. Remember, carries the molecules through the column. Okay, and these columns separate out the mixture into individual components like this and like this. Okay, so these molecules adhere more strongly, these green molecules adhere more strongly to the stationary phase, and that's why they get retained at the earlier phases of the stationary phase. These red molecules will not show highest affinity and will travel to the end of the column, and they travel faster. Okay, and they are eluted out first. Okay, so this is how the gas chromatographic techniques work. Third, the components are recorded as a sequence of peaks as they leave from the column. Remember, if you have two components like this, the first one is denoted by this green color, second is denoted by this red color. That means first the red color components will get eluted out, it will show you one peak. Okay, now simultaneously the mobile phase will carry out the separation of these so-called as strongly attached green components. These green components will give you second peak. That means you come to know that there are two components in a mixture which we have dealt in the gas chromatography. Okay, This is how this whole process can be visualized. Remember the separation column. Look at the column. Look at the column and its length. Its length is very high. A large column has been used so that the surface area gets increased, and these compounds will show you affinity or separation likewise. Okay, so thank you to this Bharadwaj Reddy. We will have this excellent working principle in case of your gas chromatography. Look at this. These compounds will be this mixture will be inserted into the column by using this sample wall, and this carrier gas allows the passage throughout the column, and this will result into separation of individual compound just like this. The first one is red, second one is a green, and third one in the last, which will have highest affinity, will be in the last, that is yellow. Okay, so that's all regarding principle. Now, how this gas chromatography is different from your column chromatography, maybe HPLC, maybe TLC. First difference is that the process of separating the compounds in a mixture is carried out between the liquid phase and the gas mobile phase, and that's why it is called as a GLC. Remember, in case of liquid chromatography, this is LLC or LSC. Okay, so first difference in case of HPLC, or more specifically column chromatography, is it employs liquid as a stationary phase and gas as a mobile phase. Okay, second is what? Column through which the gas phase passes is located in an oven where the temperature of the gas can be controlled. Okay, whereas in column chromatography, no such a temperature controlling facility will be available. Remember, this is the heater, so that your carrier gas along with the sample will remain in the vaporized state throughout the column. Okay, why this heater has been employed? Okay, this heater has been employed because you need to maintain this gas sample and carrier gas in a gaseous state, and that's why this heater has been employed in a separation column. This is not the case with respect to your liquid chromatography, okay, or column chromatography. Okay, this is the second difference. And third difference is concentration of the compound in the gas phase is solely the function of vapor pressure of the gas. Remember, as the vapor pressure generated by the compound will be the functionality between the separation of your compound between the stationary phase and mobile phase, and the compound which does not generate the vapor pressure of a significant quantity cannot be separated out in case of gas chromatography. This is not the case with respect to your liquid chromatography or column chromatography. Okay, so we will deal it with the stationary phase. As we all know, mobile phase in case of this is inert gas carrier. Stationary phase is what? Liquid coated. Remember, coated liquid, because we are dealing with most of the time GLC. Okay, so the liquid component in case of this is liquid coated on a solid or a solid within the column. But solid, as we all know, stationary phase solid is not so significant or not available in number of quantities, and that's why the stationary phase has been limited to the liquid coated on a solid, and mobile phase is called as a carrier gas. Now, how this exactly chromatographic separation will occur? In the mobile phase, the components of the sample are uniquely drawn to the stationary phase and thus enter this phase at a different times. Depending upon their affinity towards the stationary phase, these compounds will travel at a different speed towards the elution or rather detector. The parts of the sample are separated within the column, as we have already discussed it or even visualized in case of our diagram also. The compounds used at the stationary phase reach the detector at the unique times and produce a series of peaks along the time sequence. Okay, each compound has its unique time to reach at the detector. Each compound compound will have its unique time to reach at the detector, and as soon as it reaches the detector, it will result into a peak. For each component, it will have its unique peak. That means the red component will show you a peak over here, the yellow component will show you the peak over here, and the green component will show you the peak over here. This is how the separation will be occur. Just like this, analytical gas chromatography will result into separation where these compounds will be separated out like this and it will be eluted out. Okay, the compounds used over here is a nonane and a decane. Okay, the nonane compound is denoted by these blue lines or blue compounds, which is eluted out first, and then decane, which is eluted out and later on. Okay, first is a nonane will be get eluted out. Okay, and then it is your decane. Okay. The peaks can then be read and analyzed by the forensic scientist to determine the exact components of the mixture. These peaks are then can be so called as compare, analyze with respect to the reference standard, and you will come to know the components of the mixture. The retention time is determined by each component reaching the detector at a characteristics time. Remember, the retention time, as we all know, the characteristics time required for substance to be get eluted out will be characteristics for individual components, separate components, and thus the separation through the chromatographic columns occur. The number of components in the sample is determined by the number of peaks. The number of peaks will be synonymously or rather proportional to the number of components in a sample. Okay, the amount of a given component in a sample is determined by the area under the peak. As we all know, the area under the peak will result into the amount of sample present in the mixture. Okay, this area we have already dealt it with. Okay, the identity of the components can be determined by the given retention time. A retention time with respect to the reference standard will give you identity. That means qualitative estimation will require a reference standard to compare it. Amount in case of this will require what? Quantitative analysis. Okay. So I think this is the schematic diagram in case of gas chromatography. We will deal the instrumentation part in the next lecture. Okay, you will have 150 lecture. At 150 you will have a lecture of cognosy, and the practical part I will be providing you a link of assay of trimethoprim tablet by using extraction techniques. So I will be providing you a link in your group. Okay, so we will meet tomorrow. Okay, so I think that should be sufficient for today. If you have any question, just 1 to 2 minutes, I will complete it. Okay. Okay. So I think that's all for today. We will meet tomorrow.